All right, guys, so now that we have practiced solving exponential and logarithmic functions, we're going to finish with solving natural logarithmic functions, okay? So where the base is not just 10 or 2 or some other number, it's actually the constant e, okay? So natural log is when the base of a log is e. So let's say that we have log of x. We know this to be the same as log base 10 of x. Okay, and just to recap and reminder, the log, whenever the base is e, is the same as just saying the natural log of x. Okay, so we're going to practice these kind of manipulations and these rewrites and solving expressions as far as with natural logarithmic functions. Again, our focus is to start by doing non-calculator procedure steps just to ensure that we know all of the manipulations that are occurring with the exponential and logarithmic functions, okay? All right, so let's go to them again. Number 8 says rewrite as a single logarithm. Notice right off the bat, this is not saying solve. It didn't say solve for x, because if it said solve of some kind, then there would be equal sign and there would be something on the right where your ultimate goal was to solve for x, or the variable that it said to solve for. It could be t, it could be whatever. But I want you to know this is not a solve equation. This is simply a rewrite expression. Okay, so this is an expression that we're going to rewrite it using our laws of logs and stuff of that nature. Okay, so first what we should see is the subtraction sign, which is showing that we have this first monomial piece here and the second monomial piece here. And then we can use laws of logs to rewrite this and kind of try to combine them together. Okay, so natural log of a cubed is the rewrite of this first one, and that's from a law of log that we know. We simply move this to the power of the argument. And we're going to do the same with b. So it has minus the natural log of 2 raised to the power of b. Okay, that's step 1. Now, we have natural log and natural log, which is the same as log base e. So what we see right here could also have been written like this. It means the same thing, log base e of 2 to the power of b. And the reason why I show you that is because laws of logs, if we have the same base with the subtraction, we can combine these arguments as division in one single logarithm. Okay, so let me go ahead and show you from here what's happening. Okay, because these bases are the same, they're base e, I'm going to combine these natural logs into one huge natural log, if you will. And again, because this was subtraction, it will be a division here in this one single argument. Okay, a cubed came first, and it's thus divided by 2 to the b. So our rewrite, if you will, is going to be the natural log of a cubed over 2b. This is our rewrite as it is. Okay, now as far as simplification, this is pretty much it. Our goal was to get it written to one logarithmic function, which I was able to do here. Okay, so now let's move on to our next question. It says solve. So there's a magic word. We're not going to rewrite. We're going to solve, because over here we still have variables. A is a variable and B is a variable. But when we have solve, we will know what that variable is equal to. And notice there is an equal sign right here in this solve equation. Okay, so let's go ahead and solve for x. Our goal is to get this x all by itself. Okay, so we have to identify and kind of read it out loud. It's 5 times the natural log of 4x minus 6 is equal to negative 6. So that times already tells me if I'm trying to isolate the natural log, as I've isolated exponents and bases of 10 on other problems, I'm simply going to divide by 5. So that I have the natural log of 4x minus 6 is equal to negative 6/5. Okay? Now, you could rewrite this if you wanted to. You could see it, and a lot of people, sometimes it's easier for them to recognize the next steps and so on and so forth if they saw it as log base e. They mean the same thing. But I'm going to show you here in just a bit why this can be beneficial. Okay, this can benefit you to see what we can do next, the next step, okay? So if I'm trying to get x all by itself, I've learned recently, very recently, that if I have log base e and I want to get rid of this, well, then all I have to do is apply a base of whatever this is to both sides. So right now, these look like they're ground level right here. That looks like ground level, and the base is e. But if I'm trying to get rid of this blue log base e, I'm going to apply a base e to both sides. And notice when I do that, this becomes ground level, okay? And these are the powers. These are new powers. Well, the reason why I did that is because this will cancel, and this kind of comes downstairs on ground level as 4x minus 6. And it's equal to e to the negative 6/5. And then from here, you can see I'm just going to add 6 to both sides. So we'll get e to the negative 6/5 plus 6. And then we're going to divide everything by 4. E to the negative 6/5 plus 6 is all going to be divided by 4. And this would be my value for x. Now, some of you will not have to do all that work. You will see it right, you will see it right here. Okay, I have a natural log. How do I cancel natural log? I apply a base of e to it. So that these cancel, and I have 4x to the minus, or 4x minus 6 is e to the negative 6/5. That's what we have here. So I got to it just a little bit faster, and then the rest is still the same. Like this step will be next, and then this step will be next. But nonetheless, our goal is to show you that when you have it in natural logarithmic form, you can cancel out right here a natural log by applying a base e to both sides, thus making these into powers. Then canceling and then rewriting going forward. All you're doing is canceling that natural log. It would be the same if I said, okay, if I have x square root is equal to 25, and I told you to solve for x. Your goal is to cancel this square root. So you square both sides, and you just have x left over. That's what's happening here. Your goal is to cancel a natural log. So how do you cancel a natural log? You apply a base e to it. Okay? And just like you did that, if you had e to the x, let's say that you had e to the x is equal to 1. Well, we know x is 0 to make that true. But the way I cancel natural log by applying a base of e over here, the way I can cancel an exponential is if I apply a natural log to both sides. So if I apply a natural log to both sides, notice the difference. Here, it was a base of a power. But here, they're on the same ground level, okay? I'm applying the natural log to both sides. So when I do that, these cancel out and x comes down. And what you do to one side, you must do to the other. And natural log of 1 is 0. So x is equal to 0, okay? That's the difference between canceling out a natural log by applying a base of e versus canceling out an e to the x by applying the natural log to both sides. Very, very important, okay? So let's move on. Number 18. Oh, I forgot to give you the actual number for that. So all of this is the answer, and we can put this into the calculator by putting e over here, e to the power of negative 6/5, and kick down, plus 6 all over 4. And there's where our answer would be. Okay? And that's the same as we could put the original problem and do the solve feature just to verify, is this in fact x? So we'll say solve feature, mini3(1), 5 times the natural log of 4x minus 6 is equal to negative 6. And solve for x. And then you see that's exactly what we got when we did it all the algebraic manipulation way. Again, please do not use the solve feature. I cannot stress that enough, or you will be hurting yourself a lot because you're losing a lot of valuable experience and practice. All right, so now let's solve for x on this one. Okay, so using laws of logs, we know this is subtracting between two common bases. Okay, so remember, natural log is the same as log base e. Please do not confuse that these two, are showing, oh, these are natural log with base of e. That's not what's going on here. Its log base of e is the same as the natural log. Okay, those are interchangeable. Okay, so over here, because there's subtraction going on, then I'm going to have division between x and 5. So yes, I can combine them just like I combine common bases of 10, logs of 2, log base 2, log base 10. The way I combined those two before together, I can do the same with natural log. Okay, so we have this as a rewrite. Again, my goal is to solve for x. So I have natural log of x over 5 is equal to -1. Well, how do you cancel or get rid of this natural log? Is that you're going to apply a base e to both sides. There's your ground level. And these are now powers. So e to the power of natural log, well, those cancel, okay? Those cancel. And I'm just left with x over 5 on ground level. And e to the power of -1, you could write it like that, or 1 over e to the positive 1, okay? And that's just manipulation with negative exponents. And we have this. And right here, what you can do is just basically multiply both sides by 5. Because if I multiply the left by 5, and I multiply the right by 5, I would get these cancel to a form of 1, and it would be 5e to the -1, or 5 times 1 over e to the positive 1. They mean the same exact thing. That's what my x is going to be, okay? And yes, this could also be written as, since it's 5 over 1, you could write it as 5 over e, okay? And that's just combining fractions that are multiplied together. Again, I have 5 over 1 multiplied with this one right here of 1 over e. When you combine them, these together will become 5, and these together will become e, so that you get that value right there. Okay, so this is my answer as far as 5 over e. And if I wanted to find the equivalent as far as what is the decimal form, well, then let's put e to the 1. And there's my answer. You can't just put e in there without putting a power. So whenever you have that, you can't just press that and it will have a syntax error. You need to say e squared or e to the 1. So if you're just saying e, just e by itself, don't put 0, because then that will be 1, always. I need you to make sure that if you're just wanting to see what does e equal, well, then press 1, and it's 2.71828, and so on and so forth. Okay? Now, we have 5 over e, which was the answer, which is right here. And I can solve it using the solve feature just to check my work. So menu 3.1, we're going to solve my original function, natural log of x minus the natural log of 5 is equal to a -1. And we're going to solve for x. And notice that we get this, 5 times e to the -1. This is what we got over here. Okay. Now, if I did the same, but I press Control Enter, I get that decimal equivalent. So sure enough, my answer, any form of these that I wrote, are going to be the correct answer. Okay. All right. So what I'll say to that is this one right here would be probably the one that's frowned on because it has a negative power. Okay. And something that you can combine that with is that if I had 2 over √2, this isn't usually an answer because we're told and we're taught that we must rationalize the denominator. We don't want it to be seen that way, okay? So just something that we learned before, multiplying by a form of 1, this became 2, this became 2 √2, and that canceled to a form of 1. So √2 is my answer. So again, √2 is the same as 2 over √2, but which one is preferred? This one is preferred, not that one, because we have to rationalize the denominator. Well, this one is not preferred because we don't necessarily like negative powers, especially when you get to calculus. So you want to rewrite them as positive powers as far as e to the positive 1. Our last example, here we go. Solve for x. So without a calculator, reading this, it's 3 times e to that power is equal to 49. Okay. My goal is to isolate logarithms or isolate exponentials. So I'm trying to isolate log base something of something is equal to a number or an expression. or I try to have a base raised to a power is equal to an expression. This is when I'm trying to isolate forms, if you will. So that's why I read 3 times. So I'm going to divide both sides by 3. So I have 49 over 3 is equal to e to the power of 3x minus 5. Okay, now you've seen a lot of examples in the last couple of videos. To cancel this e, we can apply a natural log to both sides. Notice it's on ground level. Okay, when you apply the natural log, it's still on ground level. When you apply the base of e, then it's different. It's whenever you're applying it, like we did over here on these natural logarithmic functions, the base of e, these original expressions become the power. Okay, that's not what's happening here. It's still on ground level. But nonetheless, these do cancel, and this is brought down as 3x minus 5, and I still have natural log of 49 thirds. And we're almost done. All we have to do is move the 5 by adding it to the other side. Okay, and then we will move the 3 by dividing the whole thing by 3. And it must be the entire running answer. And that will be what my answer is. Okay, so now if you are asked to put it in decimal form, we're definitely going to need a calculator on this one. So we're going to go to the calculator and put in big fraction the natural log of 49 over 3. We'll close and add 5 to the numerator over 3. This is my answer. And it kind of rewrites it. And you see it broke up this 49. The calculator is already programmed to do that. It broke up. Let me show you what happened just now. This piece into natural log of 49 minus the natural log of 3. And then the plus 5 and over 3 were still there. And this, they rewrote it as natural log of 7 squared. Okay, and then everything else was still there, just algebraic manipulation and practice. And then they moved the 2 out in front to show you that the equivalent form of what I originally typed into the calculator is actually all of that, which is what you see right here. Okay, so you'll see the calculator do that sometimes. But nonetheless, we can always come up here, press Control, answer, and there's our answer for X. Okay, so to finish it off, I'm going to menu solve feature this thing and see, do I in fact get something like this? Okay, so we can say the solve feature of 3 times e over here to the power of 3x minus 5 is equal to, whoops, that's a minus, not a, is equal to 49, comma x. And you see we get, if I just press enter, that weird answer that we got before, but if we do control enter, we get the same exact decimal answer. So our answer can either be the decimal form or this entire piece right here. Just read the instructions to your questions carefully. If it doesn't specify a certain way, you could do either one. So x is equal to 2.598 would be like the decimal equivalent to this thing right here. Either one of these, since it didn't tell us specifically which one to do. All right.